Hello and welcome to my video where I'll be doing another Python tutorial. This time we'll be going over another task using subroutines. But before I do, please hit that like button, press the subscribe button and share this video far and wide. And without further ado, we're going to go into subroutines. So what task do we need to do today? Let's put it this way. You've just received a student who needs tutoring in physics for his GCSE exam. He's struggling with the different formulas and desperately needs your help. To help him out, he would like a calculator that will help him work out the different formulas in physics. So you need to create a series of subroutines. One calculation per subroutine, and it will have the following areas you can choose to calculate. Charge is capacity times the voltage. Power is voltage times the current. So these are all the different formulas we need to do. So what we can do to save time is we can just copy these formulas, and we're going to actually do shift quotes lots of times, and we're just going to do that. So we know, boom, that's what we want. So how are we going to do this? So the first thing we can do is I would be doing a menu. And what you can do, if you really wanted to, is let's find the physics stuff. Here then. So let's say I want to find the charge, power, current, resistance, and we're going to have the different options. So I've got a little bit of a working example already, so we're going to expand on that. So we've got the charge, we've got power, so we've got charge and we've got power, and we got current, and we got resistance. All of those we've got. So we don't really need to worry about any of those. So you can see we got a menu of all the different subroutines. So just press run, press 1, charge, 2.3, and let's say we got 4.5. Put the two together, there's the charge. But we obviously will need a lot more than that. So let's say we want to work out the wave speed of a formula. So you do def wave speed, then you do a print statement, and then you would do type in wave speed. So that is one way of doing it. So what do we need? We need a variable called frequency. So we could do that as a float input, and then you would have enter the frequency. Nice start there. And then we would need to enter the wavelengths, and that's going to be another float. We'll make that another float because in physics you will deal with decimals. And then what we're going to need now is we're going to need that formula. Wave speed is frequency times wavelength. So, and then we are going to print out the wave speed, and we're going to output that wave speed. What we might want to do is we may want to round this, use the round function, and we're going to round that to 2 decimal places. And then what we're going to do here is we're going to do \n/t, and we're going to have number 6, we're going to have wave speed. And there we go. And then we'll need an elif, obviously. Because without the elif, how are we going to call the subroutine? Let's go in here. 6, wave speed, let's say it's 2.345, 4 all those numbers. It's going to take us to 10.62, that's to 2 decimal places. Okay, so that is the wave speed. So let's say we want to do the work done now. And what we can do, if we really wanted to, we could calculate the work done and we could have some exception handling. So let's say we want DEF work done. We could do some exception handling there. So the way we do exception handling, okay, so you would input something, you're going to see if it's a float, if it's not, so you're going to try it as a float, and if it doesn't work, we say we haven't entered a number and we quit, and then we do the distance, same with the distance, and then once we've done that, we are going to do work done is force by distance. And then that's how we get the work done. Okay, so that is it. So that's it there. And then we will need to do the usual. And then we will need to do the next elif here. And then we can call that one work done. Let's run that. Number 7, work done, so force 23.4. And there's our work done. So what we're going to do, we are going to do the round function. 2. Let's try that again. And it's just rounded up to 2 decimal places. So we have got a lot more to do there. So you can say we've done those 2. So we've got force is mass times acceleration. So there's loads of more formulas here. So for force, we could do another. So we could do force and acceleration. So let's take those 2 subroutines. And you can bung that here. So we got force, we got acceleration. Yep, we got so for number 8. Acceleration, and then we got force. So we got another force there. So we got that one. And then we will need then we're obviously going to need the speed. But not just yet. So we got 8. That's going to be acceleration. 9. That's going to be speed. That's going to be speed. Force. So let's try force. And there we go. And what we're going to do, we're going to use, you guessed it, the round function to 2 decimal places. And it's good to use the round in a task like this because it's showing that you can do different functions. We've just got 6 more to go in a big one like this. So we need speed. So we need speed now. So we need speed, which is distance over time. And what we're going to do here, we're going to do round to, and then we're going to do number 10 here, speed, and then what we're going to do is do speed here. And there we go. So, let's see, we might already have power is worked. Power, we've already got voltage times current, voltage over resistance. Yes, there's another power unit. So we would need def power 3. Then you're going to print power. And then power is essentially work done divided by the time taken. Okay? So that is essentially what we want. Work done be float input, enter the work done. Then we're going to do time taken. And then we're going to just do a nice little float here. And we're just going to say time taken. Then we're going to print power. We're going to do round power to 2 decimal places. Oh, should put an F there for float. And then we can have, for number 11, it's power NF option. Power 3. So we got that one. Nipped in the bud. Yep, just 4 to go. So what I'm going to do, I'm just going to do that. So we got power rating, which is voltage, current. We can go back up and just do voltage and current here, because that's what power rating is. So we've got voltage and current, and then we're going to take that, power ratings, voltage and current, and then we are going to say power ratings. We're going to say power ratings. After that, we're going to say units of energy. Energy. 13. Yep, so we got, what am I missing? So power rating, units of energy. So 12 is units of energy. So power ratings. Yep, so we got power rating there. So yep, done power rating. Yep, I need to have a look back at the formulas. We've done power. So that's the next power. Now we're on power ratings. So that should be, yep, so 12 is power rating, so we were right. Voltage times the current. 13 was units of energy. Don't know why that's playing up like that. So we've got power there, power rating, units of energy, number 14, we have energy, and then the last one, efficiency. So that's all the formulas there. So we've got units of energy, energy itself, efficiency. So we've got DEF, units, energy we're going to call it, just to shorten it. Units of energy. And then we're going to have energy. Just going to have energy. And then we're going to have efficiency. So there's more formulas there. So what do we need to do now? Better idea. Let's bring those up here, so I don't have to go up and down and make this video too long. Units of energy. We need power and time. There might be a power and time one there already. Yep, so we're gonna take that. We are gonna take that one, put some exception handling in here. So we got time, and we just need the power. So what I'm gonna do float input, enter the power. Then what we're gonna do here, we're gonna do units. We're gonna do units, energy, power times the time. So that should work out okay. And then we're going to print units of energy, and we're going to do round units energy to 2 decimal places. They should all work. Maybe that might make more sense. If there's exception handling, we don't need that. So units energy. Now for energy, which is mass over latent heat. So we need the mass. SLH. And then we're going to say enter specific latent heat. And then what we need to do now is energy equals mass times specific latent heat. So the energy, round energy 2, there we go. Got all that in there. Yep, they're all used. We're making sure they're all used. Last but not least, efficiency. So output. So that's going to be useful output. And total output, so that's going to be total energy output. So we got efficiency equals output divided by total output. Then we're going to print efficiency 2. Boom, 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 boom. There we go. What we will need now is we will need 3 subroutines that are going to be called 13. That was, let's check it. Units energy, and then we've got energy, and then last but not least, we've got efficiency. $12, $13, $14, $15. We could leave it like that, but we're not going to. Let's make this more fun, because we are going to import sys os time. Reason why I've done that is because underneath here we're going to have an else statement, and we're going to do print goodbye, and then we're going to do sys exit, so that will exit the program. And then what we're going to do in all these subroutines, we're going to do time.sleep. I'm going to do that for 1 second. Then we're going to do OS system, and we're going to clear. And let's just bung those in every subroutine, shall we? Yep, it does take a bit of time. This video is a bit longer than usual because this is such a big task, and it's important we get all the points. Let's go down. Nearly there. And we could do that here too. So let's run these. It says to do 16. Yep, it's gone. Let's try 14. I'm going to do 23.4. There we go. Let's do 11. Work done. Boom. And you can get pretty much this. And there we go. So that is essentially this whole program with 15 subroutines. 229 lines. And that has taken us around 20 minutes to half an hour to do. But this is the whole program. Okay? And some of the subroutines you'll see has got some exception handling. Some of it doesn't. Oh, I hope you've enjoyed my video. Please remember to hit that like and subscribe button. And share this video far and wide, and I look forward to making the next video for you very soon. Thank you for watching. Goodbye for now.